Dear viewers, welcome to another video in the series of data analytics through Microsoft Excel. In our previous video, which is video number 19, I have explained how we can fit a bell curve in a histogram so that we will be able to see whether the data with which the histogram is drawn, is it fitting a normal distribution curve. So it's a graphical way of validating whether the data is following normal distribution or not. So during that video, I have told there are other methods of graphical representation by which we can understand whether the data follows normal distribution or not. In that, one of the methods is drawing a QQ plot. The term QQ refers to quantile-quantile plot. So in this video, we will understand how this quantile-quantile plot is drawn. So please continue watching this video till the end so that you will be able to understand the calculations, the statistical calculations, how the graph has to be drawn, and once the graph is drawn, how the interpretation of the graph has to be done so that you will be in a position to find out the data follows normal distribution or not. Let's get into the video. As I was explaining in the introduction, let's understand how we can draw a QQ plot, otherwise called quantile-quantile plot, to graphically validate whether the data is normally distributed or not. I'm using the same data that I have used for plotting a histogram with a bell curve. So in a logistic company, we have collected 150 samples of parcel and their corresponding weight, and we want to see whether the data is normally distributed or not with the help of a quantile-quantile plot. So let's quickly do some descriptive statistics. Let's calculate the average of the given data using the average function. Let us also calculate the standard deviation of the given data. So I apply the standard deviation function stdev.s, standard deviation of a sample. Why we are using stdev.s? When should use stdev.p? What is the difference between these two formulas? I have posted a separate video on this in the data analysis playlist. So kindly go through it. You will understand what is the difference between these two formulas. So here the average of the given data is 99.80 and the standard deviation of the given data is 9.30. Now we will try to understand the rank of each data point. So what do we mean by rank? So we are going to now assign rank for each data. So we have 150 data points. The minimum value, which is, so if at all we want to know the minimum value, so maximum and minimum value, let's even calculate that. So I can use the max function, and I can also use the min function. So the maximum value is 125.84 and it should be assigned 150th rank, and the minimum value is 72.41 and it should be assigned rank number 1. So this is the option of assigning rank. So what is the Excel function to do it? We can say is equal to, and then we can say rank dot avg, that is rank average. So why are we using this rank averages? If at all there are two values, same value appearing two times, then we need to take the average of those two values. That's why we are using the rank dot average. So we now need to find out the rank for this data point 91.25 among this 150 data points. Which is the rank for this particular 91.25? So what do? We select this particular data point, we put a comma, and after comma we need to say this 91.25 among the 150 data points. So we are selecting the reference value in which the rank need to be identified. So I select this value E3 to E152. As we have seen in the previous instances, we need to freeze these cells so that we can copy paste the formula. I can put a comma, I can put a comma, and after comma I need to say how do I want this rank. So if I put 1, the least value will be assigned rank number 1 and the highest value will be assigned rank number 152. So that is the last argument or the last information that we are giving to this particular syntax. So now if I hit enter, 91.25 is securing 25th rank, 104.31 is securing 108th rank. So I can copy and paste this formula or function for all these and get the individual rank. So once we get the rank, the next information that we need is what is the percentile value. Again, for those who are hearing this terminology for the first time, we have made a detailed video on what is called percentile. So simply the term percentile means among the entire set of data points, 150 data point, you can assign a rank. But if you convert that data point of 150 to a scale of 100, the maximum data point will secure 100th percentile. So the 150th rank should get 100th percentile. That's the meaning. That means you are converting your sample to a scale of 100. And how do we do that? The method to do that is you can say is equal to rank minus 0.5. Now why minus 0.5? If we don't apply this minus 0.5, then what will happen is the highest value will secure 100th percentile. And what will happen is from a normal distribution curve, the 100th percentile will have a probability of infinity, because the curve of a normal distribution curve can go up to plus infinity and minus infinity. So we wanted to have this percentile less than 1. We don't want 100th percentile. So the percentile value should be between 0 to 1. In order to make sure that the percentile value does not reach exactly 1, but it stays below 1, we are applying any rank minus 0.5. So we are not going to calculate the rank for 25. Instead, we will be calculating the rank for 24.5. Similarly, we will not be calculating the rank for the 100th rank or 150th rank. We will calculate one value before. That is 149.5. So 149.5 divided by 150. Then your percentile will not be exactly 1. So we want the value to be less than 1. So the rank minus 0.5 divided by n, which is the total number for which we are doing this calculation. So if I hit enter, this will be called the percentile. So now what we got is, we have got the rank for a particular data point among the 150 data points from which this data point is taken, and for that we have calculated the percentile. Now for this particular percentile, what will be the theoretical z-score? The next terminology that we have to understand here is called z-score. What is z-score? So friends, if you want to understand what is z-score, again I have made a video on what exactly the term z-score means. I have made a small video, less than a minute video. You can understand that. I will share the link of that video in this particular description of this video. However, to make it easy for you to understand, the average of this data point is 99.8. Let's assume 100, and the standard deviation of this data point is 9.3. Let's assume 10. So average 100, standard deviation 10. In this kind of an example, if I take 85, right, randomly if I take a number 85, you will say 85 is 15 units less than its average. You can also say 85 is 1.5 standard deviation less than its average. Why? Because my standard deviation is 10. So 15 will be 1.5 times of standard deviation less than its average. So what is z-score? Z-score is nothing but representing the actual data point in terms of how far it is away from its standard deviation. Sorry, how far it is away from its average in terms of its standard deviation. As I told, I have graphically represented this in a detailed video. I will share that link. Those who have doubt on what is z-score, I would request you to pause the video at this stage, kindly get into the z-score video, understand it, and then come back. But for your simple understanding, let me apply the z-score formula here. So the z-score formula is equal to, in Excel we have something called standardize. So by standardize, what we will do, we will say standardize the actual value, comma, its mean. So again, because I have to copy paste the formula, I am applying the dollar symbol here, basically applying the dollar symbol to freeze this cell, then comma, again I need to select the standard deviation. So this is the standard deviation cell. Again I would like to freeze this cell, right? So this, if I close and hit enter, minus 0.92, the meaning is this particular value 91.25. If I want to show you what exactly is happening, I can say is equal to x minus x bar. That means the individual data point minus its average. That means how far it is away from its average divided by the standard deviation. So when you divide the absolute difference with standard deviation, It will tell you how far is your individual data point away from its average, but not in absolute units, but in terms of its standard deviation. So it is minus 0.91 standard deviation away from its average. That is what we have done, but we have done with a we have done with the Excel standardized function. So this is the actual Z score. Now what we are going to do, we are going to now calculate theoretical Z score. What is theoretical Z score? Theoretical Z score is nothing but if a data is normally distributed, then for a data point which is going to get 0.16 percentile, which is in other words 16th percentile, what should be the actual Z score? So what we are calculating now is the standard Z score for a perfect normal distribution. So in column H, we will be calculating the theoretical Z score. In column I, we are calculating the actual Z score for the given data. If these two Z scores match with each other perfectly, then this data is normally distributed. If there is some minor differences, then also we can assume this data is approximately normally distributed. If there is huge difference, then this data is not normally distributed. So to calculate theoretical Z score, we are going to use again an Excel function which will be called norm.s.inverse. So this norm.s.inverse is a function where you can take the percentile value and close the function and hit enter. It will say for a data which is normally distributed, if there is one particular data point which is taking the 16th percentile value, then it should have actually got a Z score value of minus 0.98 as per the Z curve, normal Z curve, right? However, in this case, it is taking a value of minus 0.92. So is this minus 0.92 minus 0.98 close enough, perfectly matching? Definitely not perfectly matching, but is it close enough or very far away from each other? It's very difficult to say at this point of time. That is why we will convert these two Z scores into a graph, and that graph is what we call it as QQ plot. So let me copy these two formulas and paste it here. So now what we got is the theoretical Z score for a perfect normal distribution, and what we got in column I is the actual Z score for the given data. Now to compare whether these Z scores are matching or it is hugely differing, we can select these two values, click on insert, and then we can use a normal scatter diagram. So this is the scatter diagram that we have plotted. So let me take this scatter diagram and paste it at the top so that it becomes easy for us to interpret the results. So I have copy pasted it. Okay, so some few corrections that we need to do to start with. Actually, this scatter diagram, the x and y axis are cutting each other at a 0 point. For us to make a proper interpretation, I think it need to cut not at 0, but it need to cut at minus 3. Why minus 3? Because a Z score value can, for a normal distributed data, can take values between minus 3 to plus 3. So this side we will take minus 3, and similarly the minimum value will also be minus 3 and the maximum value can be plus 3. And the same thing that we can do with this axis, we can go to axis options and we can say, sorry, with this one we can go to axis options. It should cut at minus 3. So by selecting minus 3, we are having this x and y axis pushed towards the left hand side of the graph. That is what we are trying to do by selecting this value. Okay, now we have adjusted the scale. So what we can now do is we can select this and we can do a right click and say add a trend line. So by adding a trend line, and if we want, we can even format the trend line for our better understanding. So let me select this trend line, format trend line, and let me make it as a straight line instead of a dotted line, a solid line, so that it becomes easy for us to understand. And if we can now see this graph, if a data is perfectly normally distributed, the theoretical Z score and the practical Z score, if they match, then all these individual dots that you see here will all fall on that particular trend line. So if you see this, except for few data points here and some distortion here, more or less the other data points are falling on the line. So with this, what we can understand is the data is not perfect normal distribution. However, we can understand that approximately the data follows normal distribution, and we can call this as our QQ plot. We can call this as our QQ plot, and if required, we can, even to make it easy for others to understand what are these X and Y values, we can add a axis label to this. So we can say chart design, and we can say axis titles. So the horizontal title will be our theoretical quantile Z scores, and our vertical title will be the actual Z scores. So we can again say design chart, chart elements, axis titles, vertical. We can paste this value. So friends, I hope now you understand how each of this column need to be calculated. Let me quickly summarize. The descriptive statistics that we wanted to do this calculation is average and standard deviation. And once we have this, the first activity is to assign a rank to each of this data point. The second activity is from the rank you calculate the percentile. That means what is the value if the overall data point is converted to a scale of 100. Here you can have 150 data points, but if it is converted to a scale of 100, then the rank will be 16th percentile. Among 150 data points, this data is secured 25th. However, if there is only 100 data points, this data will secure 16th percentile. So once we have the percentile, then from the percentile we can calculate what will be the theoretical quantile Z score, and we can also calculate the actual quantile Z score. And once we have the theoretical and the actual, theoretical is for the perfect standard normal curve and actual is for the given sample data, and then we can plot this in a scatter diagram and then add a trend line, and if the data points fall perfectly on the trend line, it is a perfect normal distribution. However, in this case some data points are deviating, but more or less other data points are falling on this line. So we can conclude with this QQ plot that the data is approximately normally distributed. So similar to QQ plot, there is also another concept called PP plot, which is probability plot, which I will be explaining in my next video. I hope this video was useful for you to understand how we can graphically validate whether the given data is normally distributed or not with the help of a QQ plot. For more videos on data analysis and graphical representation using Microsoft Excel, kindly subscribe and follow our channel. In the next video, I will be explaining about the PP plot. Thanks for your time. See you in the next video.